Hey, welcome. When we think about AI, it's so easy to picture those sci-fi movies, right? These perfect calculating robots that know everything and never, ever make a mistake. But is that what engineers are actually trying to build? Today, we're going to pull back the curtain on one of the most important ideas in all of AI, rationality. And I think you'll be surprised to find out it has almost nothing to do with being perfect. So, yeah, let's get into it.
So let's just tackle that big question right out of the gate. Are we really on a path to create these flawless, all-knowing beings? Well, the short answer is a hard no, not even close. See, the goal of AI isn't to build some kind of crystal ball that can predict the future with 100% accuracy. The real goal is something way more practical and honestly, a lot more impressive.
To get why, we have to totally redefine what the word rational even means here. In our everyday lives, we might say it means being sensible or logical. But in the world of AI, it's a technical term with a super precise meaning. We're moving away from this fuzzy idea of just doing the right thing and into a solid engineering framework. And this right here, this is the absolute heart of it. True rationality in AI is not about being infallible. It's not about hitting a bullseye every single time. Instead, it's all about maximizing your chances of success based only on what you know right now. Think of it less like a perfect physicist and more like a world-class poker player. They don't know the next card, but they play the odds better than anyone else. This brings us to the official textbook definition of a rational agent. Now, don't let the words scare you. An agent is just the thing that's doing something. It could be a piece of software, a robot, whatever. And we call it rational if it always picks the action that's expected to give it the best score, based on everything it's seen so far and whatever it knew to begin with. And I really want you to focus on that one single word, expected. That one word is the whole key. It's what separates real-world AI from science fiction. The agent doesn't know what's going to happen. It can't see the future. All it can do is run the numbers and figure out the most likely good outcome. And then it goes for it. It's all about playing the odds as intelligently as possible.
Okay, so how do you actually build one of these rational agents? Well, it turns out there's a blueprint for it. Kind of like a recipe, with 4 essential ingredients that any designer has to figure out before they can create one.
These 4 things are the absolute building blocks. First up, the performance measure. You gotta ask, what does winning even look like for this agent? Second, prior knowledge. What info are we giving it right out of the box? Third, what are its possible actions? What can it actually do? And finally, its percept sequence, which is just a fancy way of saying what's the complete history of everything it has seen, heard, or sensed up to this very moment.
All right, that's a lot of theory, so let's bring it down to earth and make it super tangible. We're going to apply this 4-part blueprint to something a lot of us actually have in our homes, a robotic vacuum cleaner. I promise this will make it all just click.
So let's break it down for our little robot vacuum. Its performance measure isn't just get the floor clean. A really good one also has to think about how much battery it's using, how long it's taking, and maybe not making a ton of noise. Its prior knowledge could be a map of your living room that it starts with. Its actions are pretty basic. It can move, it can turn, and it can turn its suction on or off. And its percepts, well, that's all the data streaming in, the camera feed that spots a crumb, or the bumper sensor that says, whoops, just hit the couch leg.
And now we get to what might be the single most important idea in this entire explainer. Really getting the difference between being rational and being omniscient, or all-knowing, is the key to understanding all of modern AI.
Yeah, putting them side by side like this makes it totally clear, doesn't it? The rational agent on the left is a strategist. It's working with probabilities and making its best educated guess. The omniscient agent on the right, well, it's basically a fortune teller. It knows the actual outcome with 100% certainty. One of these is an achievable engineering goal that powers the world around us. The other is a total fantasy.
So this is where it really comes together. Imagine a self-driving car pulling up to an intersection. It scans everything, pedestrians, other cars, the light, and based on all of that data, it determines it is perfectly safe to go. It makes the rational choice to drive forward. And then, in a totally bizarre, 1 in a billion fluke, a small meteorite falls out of the sky and hits the car. Now, was the car's decision to go irrational? Of course not. Based on all the information it had, it made the absolute perfect call. This proves the point. Rationality is about the decision-making process, not the final, unpredictable outcome.
So that brings us to the next really fascinating step. A rational agent isn't just a static thing. It's actually designed to get better, to evolve from just following its initial programming to becoming truly independent by learning from experience. Yeah, when you first turn an agent on, it's running on its factory settings, you could say. It's using the prior knowledge and the rules its creators gave it. Think of it like its starter instruction manual for how to deal with the world.
But look, a rulebook can only get you so far, right? It'd be pretty limited if it stopped there. The real magic happens when the agent starts to learn from its own percepts, from its own experiences. It starts rewriting its own instruction manual as it goes, becoming way more effective than its original programming ever could have been.
And there's a name for this amazing ability to learn and adapt. We call it autonomy. A truly autonomous agent starts to rely more on what it's learned for itself than on that initial rulebook it was given. It basically becomes its own expert. So at the end of the day, learning is the engine that drives autonomy. It's what allows an agent to adapt to situations its own designers might never have even thought of. It's the huge difference between a fragile machine that can only do one thing perfectly and a flexible, tough agent that can actually handle the messiness of the real world.
So, why did we just spend all this time talking about definitions and robot vacuums? Well, because this whole framework, it's not just some abstract theory in a textbook. It is the fundamental logic that makes so much of the smart technology we use every single day work.
Seriously, think about it. From the navigation app on your phone that's picking the best route through traffic, to the recommendation engine that suggests your next favorite show, all the way to the self-driving cars being tested on our roads. They are all at their core built on this principle of being a rational agent.
And it's kind of wild to think that it all comes back to just those 4 simple building blocks we talked about: defining what success looks like, having some starting knowledge, knowing what you can do, and then constantly paying attention to the world around you. That 4-part structure is what allows for all of this incredibly complex behavior.
So look, if you take just one single thing away from this explainer, let it be this. The goal of AI is not to build a perfect, all-knowing God in a box. The goal is to build systems that are just exceptionally good at making the best possible call right here and right now with whatever incomplete information they have.
And that leaves us with a final and pretty crucial question to think about. As these agents get more and more autonomous, learning on their own, defining their own paths from their own experiences, the really big challenge is going to be making sure that their performance measure, their definition of a good outcome, always stays aligned with what we as humans actually value. And that's the challenge that's going to shape our future. Thanks for digging into this with me.